Hello friends, you are welcome again. Alright, so quickly in this video, I'm going to talk about certain important aspects of electrical installation work that you need to take note of as a wiring professional. And I will encourage homeowners also to watch these videos because it will help you and guide you so that at least you can also have an idea when somebody is wiring up your facility. Okay, so in this video, I'll talk specifically about load calculation. Load calculation. Okay, so when we talk of electrical load or when we say load in electrical wiring, we are only referring to the gadgets and the items that you will be installing in your facility or in your house that will need electrical power to work. For instance, this chandelier I'm fixing here is an example of electrical load. The lights you fix in the rooms and outside the rooms are all electrical loads. The fridges you'll be using, the blenders you'll be using, the televisions you'll be using, all these are known as electrical load. Very well. So then, when we are talking of load calculation in electrical wiring, we are simply referring to the process of determining the total electrical power that will be required for the various circuits in the wiring and for the whole electrical system in the facility to work properly and safely. And if this is done correctly, you will be able to select the right sizes of cables for every circuit in the wiring. You will be able to select the correct breakers to properly protect the various circuits, and you will also be able to select the correct size of consumer unit and the correct size of main cables that will supply your installation. Okay, so how do I then do my load calculation? How do I go about it? All right, so first of all, in the load calculation process, the first thing you need to do is to list all the electrical loads that you would have in that wiring. So if it's a new wiring, you must have an idea of the particular loads and their numbers that he would want to use in that facility. For instance, in every facility, in every electrical wiring, we know there must be lights, okay, lamps. And if there are going to be special lamps, like the one I'm fixing here, or special lights that will consume more electricity. Okay, so after you have listed your loads, the next thing is you will have to determine the power ratings of each of the loads. And this is the first thing that must be done before you even do your estimate. Okay, it is after the load calculation that you can be able to tell properly that I need this or that for the wiring. Without proper load calculation, you can't just buy anything. And that is why most of the time you realize that you end up overloading the circuits in the wiring. Okay, let's go on. So, how do I determine the power rating when the client is yet to buy the items? Okay, so most of the times we do this by questioning and then assumption. Okay, so you have a house to wire, and then the client tells you that I'll be using chandeliers in all the halls. I'll be using chandeliers in all the open porches. I'll be using chandeliers in all the rooms. So this gives you a clue that in a normal room where it would have been enough to use just two lamps, you may end up using three lamps. And usually, chandeliers consume higher than the normal LED lamps that we use in the room. So, for instance, this is an example of a chandelier in a room, and this is not alone in this room. So, you realize that the chandelier alone has three lamps. So, under normal circumstances, you are adding more load And this room, if all these lamps should be on in this room, you will be consuming double the amount of current that another room that has only two normal LED lamps will be consuming. That is simply what it means. So, in assuming the power rating of the lighting system in this room, you cannot just do it by counting the number of rooms and assuming anything. You have to have an idea of the things that will be in that room, like the number of lamps, the type of lamps, the number of fans, and if there are other things. All these are going to affect your number of circuits in that facility, and it's going to affect the number of breakers you'll be needing to protect the lighting systems. So, in a normal simple wiring where you use one light in every room, you can combine like 10 rooms, and one 6 amp breaker will be enough for all the 10 rooms. But in the example I have just given, where you are using so many lamps in one room, combining 10 rooms on one breaker may not be safe for your cables and may also be too much for the breaker to bear. So, even in the case where there is no fault, your breaker can intermittently trip, and we don't need that. So, in order to avoid all this, from the beginning, before you start work, you have to know or have an idea by questioning to be able to assume the total power for every circuit, and that will guide you to know the number of circuits you are creating for the lighting system in the facility, and that will also determine the number of breakers you will need to protect those lighting systems in the wiring, and that in effect will determine the size of consumer unit that you use for the wiring. Okay, so practically the number of circuits you have in a wiring is not determined only by the number of rooms you have, but more by the number of loads that you have in that room or in those rooms. Okay, let's look at a practical example from here. Now, fixing these two chandeliers at the same place. First of all, we have to know if you can add these two chandeliers to an existing circuit, or if you have to wire the two in a separate circuit. And what protection would you use for these two chandeliers in one circuit? So to be able to properly determine that, we would have to first of all need to know the amount of current that each of these lamps will require to work, and that will inform us to know whether we can add it to an existing lighting circuit, or we would have to create another circuit for these two, or depending on the power rating, we may even have to create separate circuits for each of these two. All right, so the information about how much the lamp consumes can be found. This is a LED lamp, so we can find that information on the LED driver. Okay, so let's go and look at that. So here, this is the LED driver that powers this chandelier. So if you look here, we are looking out for current. So if you find current, it's okay because the circuit breakers we'll be using are rated in amps already. So if you see the rating of the lamp in amps, then you will not have to do any calculations again. But if you can't find it rated in ampere, then you have to look out for the rating in power, and then you would also have to look for the voltage. So the power and the voltage will help you to calculate the current. I have videos where I have talked about how to calculate for current if you have power and voltage. So in case you are not familiar, you can look below the video list under the description of this video to get familiar with how to do those simple calculations. So here we have 5000 milliamps. It's already rated in amps, so we don't need any calculation. So 5000 milliamps simply means 5 amps. Okay, so each of these chandeliers is rated 5 amps. So 2 will add up to 10 amps. So here, Knowing the amount of power that these two chandeliers are pulling, this information will help you to wire them safely. Okay, so how do we go about this? How many circuits do we put this? Do we put them together in one circuit and protect them with which breaker? Or we separate them and protect them with which breaker? All right, so if you are watching this and you are already an electrician, it is general knowledge that lighting circuits are protected with either 6 amps or maximum 10 amps. Okay, now these two are already 10 amps and the wiring has already been done with 1.5 millimeter squared cable, and that can safely withstand 10 amp. And then we are putting only these two lamps in one circuit and then protect them with a 10 amps breaker. So anytime more current than 10 amps wants to flow in this circuit, the breaker would have to trip, and that is perfect. All right, so in the same way, you can have just one hole, but depending on the type of chandelier you are going to use, so by the time you have done your calculation properly, you realize that putting the loads in that hole on a 6 amp breaker would just be nuisance. So even when there is no fault, your breaker will keep tripping because the total load will now be more than the size of breaker that you are using. All right, so I believe this is going to help you a lot in your next electrical wiring. Please, if you are an electrician, I suggest you subscribe for more of these educative videos. I'll be doing special videos for homeowners. I'll give you clues that will help you to know what to expect from your wiring, depending on what you want and how it is going to be done. All right, so there are more videos that will be coming for both homeowners and electricians that will help you to know how to go about your electrical things in your house. All right, so the next video will be on how to practically do continuity test on an electrical wiring after you are done. Thank you very much for watching this video. Please stay connected and let's learn together.